And we're live.
Hi there, good morning, and pleased to have you join us today. Welcome to the CDO MIT Symposium today. Pleasure and honor having Professor Alex Pentland with me today. Professor Pentland is the Professor of Media and Arts at MIT, and today we're covering the topic of Web 3.0, the good, the bad, and the ugly. Over to you, Professor Pentland.
Thank you. Thank you. So I'm going to talk today about Web 3, which is this very confusing area with an immense amount of hype. If you looked at the hype cycle, it would be right at the beginning, but the amplitude is already crazy. And the question that people have is, what is all of this? Is this making any sense at all as a business? What's happening globally? What should I pay attention to? And the fact that the news and all of the sort of stories about it are dominated by what a friend of mine calls the crypto bros makes it very confusing. So what I want to do is take a very different perspective on it. I want to take the perspective of what are the forces that are driving this, and particularly from a global perspective. And you can translate that to your own country, of course. And what are the things that are doing? Who are some of the major actors that you probably don't know about? And then sort of end up on talking about where are the likely big-time players that will determine what happens? What are the competitions? What do you have to watch out for? And such like, okay? And I'm going to leave lots of time for questions at the end because this is such a new thing with so many different perspectives that there's inevitably lots and lots of different perspectives. So I want to start by doing the normal thing here, which is sharing my screen. And you should be able to see that. The good, the bad, and the ugly. And what I want to do first is to be able to introduce myself a little bit. So I run a group that is unusual in academia because we include both research scientists, of course, sort of social scientists, computer scientists, but we also have a crew of people who actually build stuff. So most of the authentication capabilities in the whole world run on software that we develop. Most of the identity mechanisms are run on standards that we help to develop. So we keep our pulse on what's actually happening. The way to think about this is most academia fits in this sort of area that where you see these two axes about research. One axis is it practical? So look at the bottom there. There's Edison. Edison was the stereotype of practical. He was trying to make a light bulb or a photograph. And he wasn't much interested in the basic elements of it and so forth. Or someone you might not know, Tycho Brahe, which is sort of low. He was just trying to describe the way the planets moved and write it down for years. But that was critical for developing theories later from people like Copernicus and onward. And another axis is this quest to understand. So Tycho Brahe was not really trying to understand, nor was Edison. On the other hand, Bohr, who was a physicist who first discovered the structure of the atoms and things like that, was very interested in the basics and sort of, although his work led to nuclear weapons, he wasn't after that at all. He was trying to just do the science. There is another quadrant to this, though, which is people that are interested in the practical things, but also the fundamentals at the same time. And Pasteur is the poster child for this. So the idea that you can look at real life problems that have enormous impact and not just solve them as an engineering problem, but actually ask about the fundamentals so that you can potentially solve them for all time or very broadly. And that's what we try to do. So we are not just academic in that negative sense. We actually build stuff that actually works in the real world, but we're trying to do it in a principled way that can be generalized to other things. And recent things that we've done is we helped the government of Switzerland through Swiss Post, Swisscom, set up a Web3 system. Nation states, trading nation states, are setting up Web3 systems. So crypto bros, yeah, okay, that's great. They have $1 billion. Switzerland's a little bigger, a little more established. What are they doing? We helped Fidelity and the 18 largest US banks set up a similar system that's not a blockchain system, but it's a way of dealing with bank accounts and money laundering and things like that without sharing data. And so we've seen a dramatic uptick. We now handle something like 3/5 of all the bank accounts in the entire United States and half of the credit cards without sharing data. Whereas previously, you had to have your login credentials, and then the new party would web scrape your original account. Oh my God. And then, so that's all been replaced with a token system where people ask each other questions and get certified answers. And as a consequence, the US banking system is tremendously safer than it was. And that's a little company called Akoya, which you can look up. We also have done country scale things. So we actually do things with hundreds of millions of people in terms of analyzing data for store closings, for store openings, for economic forecasting. And I'll show you some of that. And have been very important in GDPR, the Sustainable Development Goals, et cetera. So that's who you're listening to and what we do. And now let's get to what's actually going on. So the core thing, of course, is that the world is becoming much more digital. There's, of course, a sort of a gold rush to be part of that and a fear of being left out of the gold rush. And our job at MIT, I see as being make sure this turns out well. Because it doesn't have to turn out well. It could be something that makes 1984 look like child's play. It could be something where various segments of society get left behind. How do we actually do that? And one of the things to pay real attention to is China. So Xi, who's the president of China, has said things like, he who has the data has the initiative. And he's exactly right. He's also said that data is a new fundamental means of production like capital or labor. So think about that for a second. So here's one of the leading figures in communist ideology saying that Marx missed 1/3 of all the major production capabilities, which is data. And that's what they're going to focus on. So as a consequence, when I ran a session on this sort of topic with a collection of world leaders, it's called the World Leadership Alliance, 2/3 of them thought that governance was the most important issue in this race towards a digital world. In other words, who controls the data? What are the rules for sharing data? What are the rules for transactions and the finality of those transactions? And everybody around the world is building these things. And forget the crypto bros. Switzerland, China, people like Singapore are doing this. Other nations are doing this. They all have different rules. They all have different attitudes about who should be able to control the data under what conditions. And this really mattered to them because it's much worse than the breakup of the internet into different sections. This is the breakup of everything, trade, finance, information flows into these separate walled gardens that are controlled in different ways. And so that was the thing that they were most worried about. And probably you should be most worried about too, because these are the headwinds you're going to run into in the next few years if you're an international company. And even if you're just a national company, we are going to be buffeted by this, about the fact that large fractions of the trade environment are suddenly moving to control on different platforms with different rules than what you're used to. So pay attention. So what did G mean when he said, he who has the data has the initiative? Well, let's just take a look at some sort of simple type of data that we and other people have been collecting and ask, what would it be possible? And so we've taken data from studies. We have most of the major cities in the US, for instance, and looked at patterns of buying, patterns of mobility. And what it turns out is you don't need individual data to do a lot of the things I'm going to show you. What you need to know is you need to know things like income, age brackets, etc. But you also need to know where people work, where they shop, the sort of rhythm of the city, things that you probably don't know today. In fact, very few people know this. The only reason that we have this data is that we're a neutral party and can do this on a research basis. But now the world is changing enough that you can have access to this sort of data on an anonymized basis so that it's safe, it's GDPR compliant. And what that does is that gives you a far better picture of what's going on in the community. Okay, well, great. So what? You probably don't have, I'm sure you don't have this sort of data unless maybe you're Google. So what? Well, so what is that you can do economic predictions dramatically better than today's techniques. And this is what Xi meant, is that this happens to be Beijing. We did an example in Beijing. We could predict financial growth and financial change dramatically better than their existing techniques because we knew the flows of people, where people went to shop, where people went to work, what were their paths, and so on and so forth. And that, of course, underlies most of everything. I mean, if cities, if neighborhoods are doing well, those are good places to invest. Those are good places to set up stores, et cetera, et cetera. And that's sort of the heartspring, the clock spring of the economy. In particular, it has real implications, concrete implications for investment. And what we've done and are doing now for many different entities is we can take data like this and we can evaluate where is the best place to put a particular sort of outlet or a particular sort of item, where to put your stores. Which stores are the best ones to close if they're having problems? Where should you put transportation? Where are the skills you need for the work you anticipate? Where in geographically are they? How likely are they to come and work for you? Things like that for a given sort of a price. And a way to think about this is, if you have a street corner and the people who walk by that normally on the way to shopping, on the way to entertainment, are the people who buy your product, then that's a good place for a store. But if nobody walks by that street corner that is your sort of customer, then it's a bad place. Similarly, if the people who walk by that street corner have the skills you need for your business, then they're much more likely to sign up and become an employee, work for you, be happy about it. Whereas if nobody does that, they have to take a special trip. They're less likely to apply, so on and so forth. And you can analyze patterns of this now to be able to ask, well, what would happen? How resilient is this pattern of employment? So yes, you can maybe hire the people today, but what happens if transportation changes, if other sorts of things happen? How resilient is my employment resource? And now, because you know the patterns of people and skills that they have, you can ask questions about the resilience of your location, of the skills that you're hiring for, and so on and so forth. And we can show that this is really important in a downturn, like what we may be facing, because you can look at labor mobility as well. So if you need to hire more people quickly, can you do it in this place, or should you be in another city? Those sorts of questions. So those are the sorts of things you may not have thought about because we never had this data before. And now we have this data. And that is what G was referring to when he said, they that have the data have the initiative. And we've done things like this over the years. You can do this on a larger scale. You can map poverty with this sort of data. Where exactly is the problem occurring? You can map crime. You can even do future crime, I'm sorry to say. But it's not individual future crime. It's like you can predict where there are ghettos that are likely to see increases in crime because they're ghettos. And of course, the obvious thing you do is give them more access to opportunities so that they don't have that spike in crime. The bottom line there, of course, is then you can begin looking at where to invest, and not only for your own good, but for society's good. And these are the sorts of things that we've done over the years. I'm on the board of directors for the UN's Global Partnership for Sustainable Development Data. And these are the sorts of things that we help nations begin to move towards. So, amusing story, I got named as by the Secretary General of the UN as one of his data revolutionaries, which made it very difficult to get through security points at the UN. Because this guy would have gone and said, I'm a data revolutionary. you know, really know quite what to do with that. But it worked out. Anyway, so there's enormous opportunity there to be able to look at trends that you can't see today because the data now gives you insight into these sort of trends. However, you're thinking, well, it's all wonderful, but I don't have this data and nobody's going to give it to me. And you're right. It just doesn't get happen. Data is increasingly locked down because as people appreciate its value, both to individuals, but to companies and to nations, you see laws against moving data out of nations. You see additional restrictions on sharing data. You see additional sensitivity. What are we going to do? And this is really, to me, the primary motivation for Web3. How can you make these sorts of investment decisions that I've been talking about that are possible with very extensive, rich data, but without sharing data? Sounds like an impossibility, but it's not. There are technical solutions for this that are deployed today and working. I talked about all of the bank accounts in the US. That's a working system. 3/5 of the bank accounts in the US and was spun up in only 2 years. So it's not something that's enormously complicated. So that's what I want to share with you is that how this sort of notion of Web3 is getting wind behind its sails. So the way we start to think about this is by how can we get the value from data without actually sharing the data? And the answer at a very top level is you share anonymous insights, insights about groups of people. You can't identify individuals. And you want to be able to ask, well, where are the skills in this neighborhood? What are the skills in this neighborhood? Well, that doesn't refer to any particular person, but that's what you need to be able to know about what are the sort of jobs that are likely to be filled in that particular location. And we have an architecture we call open algorithms, which underlies these things. And it's basically this change in mindset, which doesn't come easily to humans, but it comes great for computers, which is instead of moving data to code, or having a centralized data processor, you move code to the data. So you go to where the data is, they run the code there and send back statistics to a centralized location. Statistics that don't refer to any particular person. And you can do virtually everything in this sort of framework. And it's important because actually it's cheaper, it's less communication bandwidth. You don't have to have a uniform data model. Usually in implementing AI and things like that, 80% of the cost is in cleaning the data and moving it to a uniform data model. But in this sort of thing, you don't need to. You see the elements to facilitate this in things called data fabrics these days, which are basically APIs for asking questions of other people's data. Other people could be people in your organization, other silos of data, or could be outside of your organization, like we did with Akoya and the US banks. And as I mentioned, there's Akoya. We've also done this for the EU government. So they have a problem that you can't move data outside of their countries. And they have very strong privacy regulations. But using this architecture, they can calculate all the things that they need to do to be able to run Europe, but without sharing data. You just share statistics or insights about data, not the data itself. What this requires, of course, is getting the right statistics from the data. And that's the topic of private federated learning or private federated AI. And it's one of the fastest growing areas of AI. It's a way of asking questions of people that don't endanger their data, but do give you insights. And this is not something that is expensive and exotic. It's different. But for instance, if you have an Android phone, the way your typing works on your phone is something that is updated regularly using this. So billions of phones are updated regularly using federated data where the communication is encrypted, it's completely secure, data never leaves your phone, but yet Google gets the insight, or Android gets the insights that let them make their systems perform better. And there's a whole literature about this. The importance is that it's privacy preserving, preserving the proprietary data, and national security. So just sort of think about it this way. Is if you need somebody else's data, today you would sort of by default go to them and say, well, can I buy access to your data? And they're likely to say no, because they don't know exactly what the risks associated with that are. But if you go to them and you say, we'd like to know certain statistics about it, and here's the code that does it, and here's the statistics, and this doesn't threaten any privacy, it doesn't tell me about your overall database, it's just certain, sort of likely, slightly odd statistics about things, they're much more likely to say yes, and the price is going to be a lot less too, okay? And that's what we see, is it becomes much easier to access data. If you're not asking for the data, you're just asking for descriptions of the data. So Akoya, again, most of the bank accounts in the United States. And this is much more secure because you're not having copies of the data everywhere. You're just sending questions and anonymized statistics back and forth. So from a cyber attack point of view, this is almost a necessary thing anyhow. And it's cheaper because you don't need new data centers. The bandwidth consumed is much less, which is why, for instance, Android uses it. One of the reasons Android uses it and so forth. There's some papers about it. And this change makes it something that, for instance, the privacy advocates, the EU, really interested in this. They see it as a solution. As we mentioned, we got the EU data statistics organizations to adopt this sort of framework. It makes it possible to use and maintain data without holding or owning it. It just changes the business proposition completely. And what we see in the future that you'll see data markets that don't have any data. What they have is they have insights about data. So there are markets for insights of data rather than markets for data. And that will lead to a much more liquid situation where access to data becomes fairly easy through this insight mechanism. And you'll be able to sell where to put the stores, who to hire, so on and so forth, much more accurately than you can today. This framework also makes for auditability. So if I am sending messages to people and getting responses, then I know all of the use of data in my system very explicitly. And I know the answers that came from each element of the database in a way that I wouldn't normally use if it were all a centralized database. And what that means is that you can go in and watch for cyber breaches much more easily because it's made explicit. You can do financial auditing, security auditing much better. And we've done things, for instance, in different countries with the help of the financial support from the Inter-American Development Bank. We've actually put in auditing mechanisms for payments in several countries in Latin America, Mexico, Nicaragua, Brazil, Colombia, where we were able to actually characterize the quality of their expenditures and the accuracy of their expenditures for social programs and help them improve their accuracy rather dramatically. So reducing their exclusion error by more than 20%, their inclusion error by more than 20% at a constant beta, at zero cost. So they got performance that was on the order of 40% better in terms of their accuracy of targeting at no additional cost, just simply by being able to audit things much more accurately and in near real time. And the cost of these systems, the Inter-American Development Bank paid for the cost of these systems was a few $100,000 one-time expenditure just to set them up. So it's a really nice solution from that point of view too. And what this leads to is a future when you start seeing these things, it leads to a future where you have distributed data ownership and you don't actually move data around, you move queries around. And we're all familiar with this in the case of, say, MasterCard. When I walk into a store for coffee, I put my phone down, my phone generates a one-time token, which then is sent through the network. That token has the routing. So it sends a one-time token with a dollar amount attached to it. And the token routes it to my bank with the dollar amount. The bank says, okay, he's got that amount of money, gives a thumbs up, and sends that back to the merchant. Now, the routing mechanism is called MasterCard or Visa, but they don't necessarily know what I'm buying in any detail at all. They know where my bank is, but they don't know anything about my bank account or my bank performance. They're just a routing mechanism. Similarly, my bank doesn't necessarily know anything about the merchant or what I'm buying except the price. I have a little bit more details, but just a little bit. The merchant doesn't know my bank. The merchant doesn't know any of my bank details. And as a consequence, there isn't this leaky network of data anymore. It's just these queries back and forth. And we use this billions of times a day. Works like a champ. A little expensive because of the cost of the hardware, because of the insurance that goes with it, and other sort of historical reasons. And you can imagine this with other things. So, for instance, there was a brief set of interests in vaccination. This person vaccinated. And everyone would say, "Oh my God, having a national vaccine registry, that's a nightmare for privacy, security." But you don't need that. You could use the same mechanism where I put my phone down, it sends a message to the person who gave, the institute that gave me a shot, and the person who's asking the question where I'm putting my phone down doesn't need to know who that is. The institution that gave me the shot doesn't need to know who's asking. They just have a query that's been validated. And so it's a distributed thing. There's no new copies of the data. There's no national or statewide registry. It's just the places that need to know because they actually delivered the service, and it doesn't share additional information. You can now imagine doing that with social data. For instance, some countries have begun doing this with social payments so that when you have a social security check or something like that, it comes to you in this distributed fashion rather than there being a list of all the social security recipients. And this type of system, taken in aggregate, is called digital identity. And the estimates from different deployments of this type of thing around the world is that can add a huge amount to GDP because it reduces fraud, it reduces cost for repeated AML, KYC sorts of checks, and of course it's safer by a large amount because it's not repeating the data everywhere and it's not sharing the data. Well, great. And people are doing this. This is supposed to be a talk about Web3. What are you talking about? Well, if you take this architecture and you say, well, what's really going on here? You see that this web in the middle is the thing that connects all the data sources. And the way they're connected is by a token that goes from A to B, and that returns some little segment of data, an approval, a permission to do something further. And that is Web3. It's just a generalized structure for being able to pass tokens to get answers and make commitments. And that's, oops. Yeah. And that's, sorry, I'm got a little out of order here. And that's Web3. Now, a question is, which I'll come back to because maybe this isn't the right place to have this slide, is different countries are beginning to take advantage of it. So now if you're a trading nation, you make your livelihood off of trading goods, trading money, trading information. And people have seen the success of these sorts of token systems, the privacy, the control of data. And they say, well, why don't we put in a web of token passing and log it on a blockchain so that we have a ledger of who gets what, when, what they paid for it, and so forth, all encrypted. And that is Web3. And as I mentioned, we helped the Swiss do this, particularly the sort of financial elements of it. And what they did is they spun up Web3, where the blockchain is IBM Hyperledger Fabric. And that is very efficient, high frequency. It was spun up by Swisscom and Swiss Post. And it's not just for money, it's also for information of various sorts, values, transactions of various sorts. And you ask, well, why are they doing that? Well, because they have to stay ahead of the competition, right? They have to have more secure, more efficient, more complete, better audited systems than anybody else. So that's why they built this. And of course, they're not the first. The first, one of the most important ones is Singapore. Singapore's sovereign wealth fund, Temasek, together with JP Morgan, has over the last 5 years deployed and tested a Web3 system for trading, for payments, for taxes, for the whole variety of things. And it's not just for Singapore. Temasek, if you remember, has something like $500 billion worth of investment in the Indo-Pacific, mostly banks and telcos. And what they want to do is they want their investments to be able to move to this type of system because it's more secure, it's more efficient, it's safer in various ways, and it's unified. It's not separate rails for all different things. And I'll also mention that one of the main things is it is not relying on rails that other countries own. And that's become very clear that this is an important thing. When the Ukrainian war started, for instance, I had very senior friends in Germany who are just completely upset about sanctions on Russia because they said, well, what happens if we're next? They want a system like this too, where it's out of the control of other entities like the US. Think about that for a minute, right? Is all the payments will no longer run on US-owned rails. In fact, we had a long talk by the CTO of Swift recently. We're moving to a blockchain. And the reason is that their clients, different countries, want to have their own ledgers. They don't want this to be a centralized ledger that Joe Biden can manipulate. You may not like that, but there you are, right? And of course, the big kahuna is China, which has been running a Web3 system now for some 5 years. It's a small system. It's only, I think, a little less than 200 million people. And there it handles all the different information that you see in cities, mobility, shipping, payments, the whole 9 yards. And they, of course, are moving this actively onto their Belt and Road investments, which are shipping throughout the Indo-Pacific and across the Eurasian continent. So what they see is they see that secure, more distributed rails for transactions generally, not just money, is going to give them a competitive advantage. Or since it's their system, they get a little privileged insight into what's going on, which you would think would disturb some of their partners, but the way a distributed system like this works is they get more insight also. So it's got ledgers in different places. And so, you know, this is the future. These people, so between China and Singapore, you see something like $1.5 trillion worth of investment that the owners are trying to move onto their proprietary Web3 systems. That's a good fraction of all the world's production already. And then there are private systems too. Like, for instance, we work with Tradelands, which is an officer of Maersk and IBM. Currently, they handle 60% of all the world's container shipping on their blockchain system. And we're helping them develop that to include payments, or customs, and things like that. So it'll be a true Web3 system, but as a private system, owned by the various parties, the people who actually move containers, but also with ledgers and control at all of the different ports of entry and shipping. And that could be expanded over time to include all sorts of things. What are some of the other things that happen with this sort of Web3 world? So what I want to do here, just let me go back for a second, is compare this to all the crypto bros. So these are permissioned chains, not unpermissioned chains. They're state actors in many cases. They have alliances with the government, or they are the government. They have high efficiency. It's nothing like Bitcoin and the mining, right? And they have comprehensiveness, which means that you get, through putting IoT pointers onto the Web3, you get to see physical goods move, as well as payments, as well as information and other sorts of value. So it's holistic, which means you can fight fraud a lot better. It also means you can optimize things better. It also means that there's at least potential, if you have the right permissions to look at these things, for a really unparalleled big brother situation, which is something that one wants to worry about. It also enables a number of other things. One of the major things that enables are smart contracts. So smart contracts take this Web3 web that moves tokens representing entities like ships and containers and money, and it moves it from one person to another on this distributed ledger in a secure way. But you can have little bits of software called smart contracts that guide that investment. So for instance, with the Singapore system in the country of Australia and trade lanes, we want to make sure that when you move things, that the tax is paid on them that's appropriate for the digital bill of lading. It's a completely automatic system. So this is what's in this container. When it gets there, you pay this tax, and that is automatically done against the letter of credit and the payment. So you get the sort of instant clearing and certainty of tax, of payment, of physical goods. And that's one of the huge advantages of this, is you can begin now having essentially a digital twin that helps you manage physical goods, transfers of value, contracts of all sorts, where there's a guarantee, an auditable guarantee, that the transaction will complete, that it won't be fraudulent, and so forth. And we begin to see that, for instance, as examples of people now using these sort of Web3 platforms for real estate, where you get perhaps hundreds of members of limited partners in an LLC own a building. This is a 120 million euro building that's owned by a fairly large number of people. What they get is they get something that's a security. So tokens, you hear about tokens. What are tokens? Tokens are like securities. They're just digital versions of security. And that's how this building is owned. You say, well, that's wonderful. Actually, the cost of setting up this sort of ownership is dramatically less. So it's a very attractive way to do these sorts of fractional ownership schemes. And an example I like is one that was done by China in Pakistan, where what they did is they sold tokens, these are securities, remember, on a Web3 system, raising something like $1 billion from 1 million people. So think about this, an LLC with 1 million limited partners. But you can do that because the incremental cost of additional partners is essentially zero. And they use that $1 billion to build a hydroelectric dam, and then you can cash in your tokens, the securities that you bought, for electricity. So what they did is they had an incredibly distributed investment scheme, all transparent because it's all on this sort of open ledger, and the contracts are visible to anyone who wants to look at them, and are bringing electricity to a region that previously it was not economic to do. Okay, so hopefully you understand from some of these examples that there's a lot more to it than selling Bored Apes and stuff like that. It really is a way of taking trade and transaction and payments and making it completely automatic, but still incredibly auditable, much more secure. It has strong geopolitical elements to it too. There are, of course, now multiple and competing national Web 3.0 platforms, plus all the private sector stuff that you hear about. So there's the high-profile things like Ethereum and Polkadot and stuff like that. It's all good. It will be good for something. But there's the slightly more quiet things like Pentland, which are run by Maersk and IBM, which already handles 60% of all the shipping in the world. And you probably didn't know about it. Other things like that are sort of underway, including payment systems and so forth. one of the things that's dangerous about this future world is that they all operate under different legal frameworks. So that appeal, seizing of assets, ability to examine data happens under these additional national laws. Those are, of course, not neutral. The platform is an extension of national power. And we have what is really sort of a race to replace the existing rails in the world for payments, for shipping, for logistics, with these more efficient, safer programs, but with different legal underpinnings. And I think that's going to be an interesting issue in the future. We have meetings with, we bring nation states together and sort of talk about this and what are we going to do. And one of the thoughts is to be able to create digital public goods that can be part of these systems so that you get a uniformity of at least some parts of the legal consequences that happen now. And for the EU, the US, who's going to come out ahead? Well, probably it'll be a mixtured system. It's not going to be one system. It'll be interledger as opposed to the internet. Meta, well, somebody has paid 200 million for them, so maybe for their Libra system. Ethereum and Polkadot could be. I'm sure there'll be places for that. But people are going to be very concerned about money laundering, much more concerned than they have about know your customer, about other sorts of consumer protection, which is going to take a lot of the air out of the enthusiasm. We see things like SWIFT and countries producing central bank digital currencies and stable coins that are true stable coins. They're not backed by algorithms, but rather by real assets. And some very large players are in the stable coin. One of the things that I've heard that's most interesting is, could you have something that's a competitor to the International Monetary Fund, special drawing rights, that's actually a currency that is supported by a basket of currencies from the BRICS, Brazil, India, China, Russia, could happen. And actually it makes a lot of sense. It would be a real earthquake to the financial system. And I know of a couple of efforts like this that are perhaps not as politically salient, but much more liquid that are underway, because there are other elements in the world that could produce baskets of value that could underlie stable coins that would make for very efficient and very different types of financial systems. The private sector, I've already talked about Maersk and IBM. I'll bet everybody who has large logistics chains is looking at it. Walmart. What would a Walmart Web3 system look like? Well, I'll tell you, it'd be one of the biggest logistics chains in the world. And it would have features that would make it better than their current system. Switzerland, finance, health, data. It's hard to say. Likely it will be a mixture of these systems. Likely there will be geopolitical tension around there. And just to sort of end up, I run a thing called Imagination in Action. We go to Davos each year and get all the different voices together and talk about things in this huge dome that the Tata family sets up for us each year. And if you happen to be in Davos, drop by. It's free. We have Michelin-starred chefs to produce the food, so it's pretty good, a lot of fun. And we have a couple of books about this if you're interested. One is Trusted Data, which talks about tokenization, data privacy, distributed systems, and then building the new economy, which really gets into the technology of Web3 and the, we'll call it sort of the politics of it too, the things that are driving. So thank you, and let's have a conversation.
Thank you, Professor Pentland. Very insightful, and thank you very much for your presentation. We've got a couple of questions which have popped up. One in particular, which I'll read out. If individual countries are building their own private centralized infrastructures that just happen to use blockchain and ledger technologies, are they really examples of Web 3.0?
Well, they're not centralized. The point is that they're not centralized. You can't have a logistics chain that includes elements from many different countries and have it centralized. People aren't going to buy that. But what you can have is a permission thing, where let's imagine that you have a logistics chain that includes 20 countries and 100 companies. You can imagine all of them have ledgers, and all of them have to approve contracts that they're interested in, that they have participation in. So it's a permissioned distributed ledger. And that is very attractive to countries and to businesses, because now they have far more insight into what's going on, at least with respect to their interests, than they would have before. And they have veto rights, so that they can actually be a partner in it. Although the thing as a whole is run by one element. But that doesn't mean that they get access to all data or rights over all data. There are tricks, however, you can do with encryption, where you have encrypted data, so you have your own ledger, you see your own things, nobody else can see it, except the person with the super user password. That's the way to sort of think about this. And there's always some trust in these systems. In the end, they can always send a guy to your house to beat you up, right? So, we live in the real world. There are ways to undermine anything that is a secure system, but on its generic behavior, it's distributed. And all of the partners have rights that can be equal or not equal or whatever, and visibility into the things they care about. And so that is very attractive to various foreign nations, operators, and so forth.
I appreciate that. And just a follow-on question from that. Who do you see as some of the kind of, you mentioned it near the end where people that are participating, like Walmart, but who do you see kind of the winners here, and why? Why would these be the winners?
Well, I think that it's pretty clear at this point that there's going to be an Eastern Bloc centered around China and its trade routes. Its trade routes are the majority trade routes, the majority of investment and purchases in Africa and South America. So you're going to see systems there that are these sort of next-gen systems. And those countries, if they're at all smart, and I've seen some of the negotiations that happen, will have rights and permissions over things that touch them. And so that's going to be one side of the world. And then I expect to see that the EU and the US will come from behind and spin up something that's a plausible competitor. There isn't one now. But I was very heartened to hear that the CTO of SWIFT realizes that they can't have the level of centralization that they have today. They can't maintain that likely in the future. Everything's uncertain, of course, but they have to plan for a higher level of decentralization and for a higher level of decentralization of ledgers. So that you get more control over the financial system distributed to the various players. And then the third thing is you see private players, and don't forget the sovereign wealth funds, right? Billions of dollars of equity that are beginning to build their own systems to guarantee trade, logistics, investment, and those sorts of blocks will be the players standing. Are there room for new companies that all that venture capital is in? Sure. But I think there's a lot less room than people think. Right? So.
Okay, that's an excellent perspective in terms of a global view of of what's happening and transpiring and what's happening there. Just another question which has come in, a bit technical, I believe. What does Nectar and Polyswarm NCT have to do with Web 3.0? Any thoughts on that?
I don't know enough about the details of that to be able to make a coherent comment. Sorry.
That's okay. Not worry. We did run just as we got a few minutes here, we did run a poll at the beginning of the event, and I'll just share with you we had 36 people participate in the poll. The question we had was, how many of your companies are experimenting with Web 3.0? And from the poll, 53% stated that they're not started. So I think this was an interesting talk by Professor Pentland to sort of set a tone on that this is real and we need to pay attention. 28% were evaluating, 8% were in pilot, and 11% were implementing. I think that was quite an...
That's interesting, yeah.
So really over 50% have really not started. Your thoughts on that, Paul?
Well, it depends on your business, right? Yeah. There are lots of businesses that will just plug into somebody else's platform. Just like today, everybody uses Swift. Fine, right? Why should I have my own payment rails if I've got Swift and the cost is low? But there are other people that really want to be able to manage, and so it's encouraging that putting this together, almost 20% have built things, are trying it out, and perhaps even like beginning to deploy, and that more than half, are actually considering it and beginning to experiment. Because you do have to be literate about it. Even if you're going to be somebody else's customer, you've got to be literate.
Awareness of it. Okay, I appreciate everybody's time. We don't have any more questions, thoughts, but appreciate your time here, Professor Pentland, and the talk here, and the time you spent with us. Thank you so much.
Pleasure.
In where we're at. Okay. Thank you so much.
Take care.
Thank you.